All right, so let's take a look at this series here. Again, we want to decide if it converges, and then we will justify our answer based off of which convergence test that we apply, okay? So let's take a look at what we have here. All right, so you can see in our denominator, we have this k raised to the 10 power, okay? Then in our numerator, we have this 10, and then we're adding on an additional cosine of 3k to it. All right, so maybe you can think that, okay, possibly we can apply the comparison test with this one. So that means if our AK is what we have here inside of our summation, then what should we let our BK be, okay? Well, usually what we would do is we would take a look at our leading terms here, but because we want to make sure that our AK is smaller than our BK, and since we're adding on this additional cosine here, and we know that cosine, right, falls between -1 and 1, so how about we let our BK, all right, be equal to 11 over k to the 10, okay? All right, so therefore, we can say for sure that our AK, which is our 10 plus cosine 3k over k to the 10, is indeed less than or equal to our bk, which is the 11 over k to the 10, okay? All right, well, if we take a look at our exponent here for our b sub k, then based off of the p series, the value of p is 10, and that's indeed bigger than 1. So based off of the p series, it converges, okay? So therefore, our summation of our bk, right, which is a summation of our 11 over k to the 10, it converges. So since it converges, then that means the summation of our ak, it should also converge, okay? So therefore, we are saying that our series here, it converges as well, okay? So therefore, our series converge, all right? And to justify the answer, we say it converges by the comparison test. All right, so let's take a look at this one, okay? So if you take a look at what we have here, we have all of this raised to the kth power. So this is one that's going to be easy to identify of which test to use here, okay? So anytime you have something like so, everything inside raised to the same exponent, then that means we can easily apply the root test, okay? So what does the root test say? We have rho, which is equal to the limit as our k goes to infinity. We want to take the kth root of the absolute value of what we have inside, okay? So we have -1 to the k times the 7k over 3k plus 9, all of that raised to the kth power, okay? So of course, if we're doing the absolute value of that, then this piece becomes positive, okay? And so then what do we have left inside? We got the limit as k goes to infinity, the kth root of our 7k over 3k plus 9 to the kth power, okay? All right, well, anytime we take the kth root of the k exponent, what do? They cancel each other out. So we just have the limit as k goes to infinity of everything that we have inside here. Okay, so we just have our 7k over 3k plus 9. All right, well, what do we notice now? We notice that the understood exponent for both of those k's are 1. Since the degree in the top is exactly the same as the degree in the bottom, then what does that mean? We simply look at the leading coefficients, and so therefore that limit would be 7 over 3, okay? All right, well, since 7 over 3 is bigger than 1, then what does that mean, right? Based off of our root test, then that means it diverges, okay? And so we can justify that answer and we say it diverges by the root test. All right, so what if we have our series actually written out with the summation? Okay, so we no longer have the summation, we actually have it written out with the plus, right? So each of those terms from the summation we have here, okay? So what we need to do is try to figure out, okay, well, what will this be with the summation? So if you kind of take a look at what's happening here, you can see that your first number that we have down here in the bottom, those are all even numbers. And then the second number that we're multiplying, those are all odd numbers, okay? And then of course, we have the same number in the numerator repeating to be 25. So how can we rewrite this summation? Well, we know for sure we have the 25 there in the numerator. And then again, the first number and the denominator that we see are even. So how can we get an even number every time? We multiply it by the 2 times some number k, right? And then what do we do to make it an odd number each time? Well, you just simply add 1 to that to make it odd. So therefore we have 2k plus 1. All right, so this would be our summation. Then if we want to go ahead and make it look a little bit more simplified, then we can distribute, right, what we have in the denominator. So this becomes 4k squared plus 2k, okay? All right, so now maybe we can apply the limit comparison test for this one. So if we take a look at what we have in our denominator in terms of our highest degree, we have that k squared. So how about we let our b sub k be 1 over k squared, all right? So what does the limit comparison test says? Well, we say the limit as our k goes to infinity, we take our ak over our bk. All right, well, what is our AK? Our AK is all of this that we have inside here, okay? All right, so we're going to have the limit as k goes to infinity. Our AK again is 25 over 4k squared plus 2k. And then we would divide by our BK, since our BK is here, which is a fraction. How about we go ahead and multiply by the reciprocal of that? All right, so then if we were to go ahead and multiply straight across, we get 25k squared over 4k squared plus 2k. All right, well, what do you notice? The degree in the numerator is exactly the same as the degree in the bottom. So what do we always look at? We just simply look at the leading coefficients to define our limit. Okay, so therefore, the limit that we have for that using the limit comparison test would be 25 over 4. So therefore, we say that our summation of our AK, it converges, okay, because we got some number, right? So we didn't get infinity, so our summation of AK, it must converge, okay? And how do we justify our answer? We say that it converges by the limit comparison test. And again, how do we know that it converges? Well, if we're looking at the P series for our B sub k here, so that we can see that P is equal to 2. Well, 2 is indeed bigger than 1, so based off the P series, we know that it converges, okay? So that means the summation of BK converges, and then so does the summation of AK.